for section 2 in chapter 7, we are multiplying powers with the same base. We're going to go ahead and highlight same base because this rule does not apply if your bases are not the same. So the rule is if our bases are the same base, we add our exponents. Let me show you why this works. If I have 4 3s, so that's 3 to the 4th power, and I multiply that by 2 3s. How many 3s do we have all together? 6. So this is 3 to the 6. So that's the same as going 3 to the 4 plus 2. Yeah. I'm okay if you just do this stuff and give me a 3 to the 6. But I really need you guys to see that it's not magic. I'm not waving a wand. I'm just not writing every single base. Okay. No, all you're doing is simplifying. That's it. We're done. So we're done. If it'll tell you specifically if it wants the value. Otherwise, just leave it in base exponent form. That's a great question. So this would give us how many x's altogether? 9. And then the same rule applies. How many 2's do we end up with altogether? So it is 7 2's altogether. Because there's 3 here, 3 here. How many are here? Just 1.
Wait, but I don't see the one on my.
There's another 2.
How many 2's are right here?
1.
When it doesn't have a power on it, that power is 1. So there's just one of them. We don't write the 1. Otherwise, we'd be writing tiny little 1s on every number we encounter. Because that's how we normally see it. So standard when there's just one of them, we don't put the 1. Good questions, guys. All right. So the rule is if the bases are the same, then we add the exponent. So let's go ahead and write that a second time down below. I wrote it. Now you guys get to write it down below. So when you have negative exponents, you still add your exponents together. So in this case, this would be 12 to the 4 plus 3. That would be 12 to the 7th. And remember, in this case, we're not getting the actual value out. We're just keeping it in base exponent form. Negative 5 to the negative 2 power times negative 5 to the 7th power. We are going to go ahead and add those values together. So we got negative 5 on the inside of our parentheses. Negative 2 plus 7 is 5. Negative 2 plus 7 is 5. So we still add the negative value to our other exponents. All right, my folks at home, make sure that you guys pause this video for a minute, do these 3 problems, and then check your answers. So go ahead and pause. All right, so let's do these problems together.
It almost like I can't put my phone up. Right, I got it.
8 to the 3 plus 6 is 8 to the 9th. 9 to the negative 3 plus 2 plus 6. So negative 3 plus 2 is negative 1, plus 6 more is 5. And then 0.5, negative 3 plus negative 8 is 0.5 to the negative 11. Okay, so we're going to look at the situation where we have different numbers, different letters. What do we do? How do we get them simplified? So we're going to use the associative property of multiplication and the commutative, and we're going to move stuff around so it's convenient for us. So we can only multiply other numbers with other numbers and only multiply the same variables with the same other lettered variables. So in this case, I'm going to group my 4 and my 9 together. And then I'm going to group my z's together. So we can calculate 4 times 9, it's 36. So that simplifies to 36. And then my z's simplify to z to the negative 7, because 5 plus negative 12 is negative 7. So this one, what is the simplified form of each expression? 36. Z to the negative 7, and I'm going to go one step further. Because I need to train you guys to answer the questions in the most complete sense, we talked about this yesterday. We don't like the negative exponents. So when we're asked to simplify, we want to make sure we move those exponents so that they're positive. So bringing it in from yesterday, this would be 36 over z to the 7. So to be in the most simplified form, you need to have all of our exponents positive. Okay. So in this case, I have 3 different numbers, so we're going to group the numbers together. I have an a and an a squared, so we're grouping those together, and the b is going to hang out all solo mu, because he doesn't have any other b's to combine with. Sorry. So we're going to go ahead and do the multiplication. 2 times 9 is 18. 18 times 3 is 54. If you don't want to multiply 18, you can go 2 times 3 is 6. And 6 times 9 is 54. We got a. When we just have a single a, what's its power? 1. So this is a to the 1 plus 2, which is 3, and b to the 4. And once again, just to remind you guys, we put our numbers first, and then we alphabetize our letters. So a's come before b's. If I had a z, he would be on the end. Okay, guys, give this a whirl. And if you're watching this video, go ahead and pause the video and try these 3 problems. We'll go over the answers in. Let's check our answers together. 5 times 3 is 15. 4 plus 9 plus 1 is 14. So we have x to the 14. Here, our poor 12 has nobody to hang with. Hij comes next. So I have J2 and J1. So 2 plus 1 is 3. And then K doesn't have any buddies, so he's just left alone. But I want to put it in simplest form, so I'm going to bump down that K.
Wait.
So we got K to the second.
So we just.
Okay. So for the next one, I'm going to multiply the 3 numbers together. My C's are going to get multiplied together. And then poor D squared, he's got no buddies to hang with. Nope. Poor little guy. So we do negative 4 times 7 is negative 28. Negative 28 times 2 is negative
56.
Okay. I'm going to add 3 plus negative 2 to get 1. So I just have 1c. I'm not going to write the power 1 because we don't write power 1.
I write power 1.
Then we have d squared. So it's negative 56 c d squared. So in science, a lot of times we have either really giant numbers or really small numbers. So instead of writing a whole bunch of zeros, whether it's on the right or the left of the decimal, we put things in scientific notation. For example, 3 times 10 to the 7th, that is a 3 with 7 zeros.
7.
So instead of writing 3 and a bunch of zeros, we write 3 times 10 to the 7th. 7 zeros, power 7. The zeros and the 7 go together. And then this would be 2 and 5 zeros. So scientific notation. So what for me, it's impossible for my tiny pea brain to multiply these two together and to write it in a way I don't have to write a whole bunch of zeros. So we use scientific notation to save us time. So we are going to we're going to use the same things that we were using before, the same process. We're going to put our 3 and our 2 together. And we're going to put our 10 to the 7th and our 10 to the 5th together. So this is a way we can take really giant numbers or really small numbers if it's a negative exponent and combine them together without using all those messy zeros. So this would be 3 times 2. And this would be times 10 to the 7 plus 5 is 12. So instead of writing 6 with 12 zeros after it, we just write 6 times 10 to the 12 because it's easier. So as you're doing these activities with scientific notation, remember it's supposed to make life easier. And as we get better, it should. We're going to do that same process even when we have a negative value, which this would be represented by -5 means I'm going to take the decimal and move it to the left 5 times. 1, 3, 4, 5. Every gap is filled with a 0. So 4 times 10 to the -5 is 0.00004. We use scientific notation so we don't have to write all those zeros down. So we're going to use the same process here. We're going to put together the 6 and the 4. And we're going to put together the 10 to the -5 and the 10 to the 3rd. 4 times 6 is 24. 10 to the 5th, so we got -5 plus 3, which is -2. And we can't leave it like that. Scientific notation says I need my numbers with only one numeral to the left of the decimal. So 24 right now has its decimal right after the 4. I need it to be right here. It's the rule of scientific notation. You can only have one number to the left of the decimal. So what do I have to multiply 2.4 by to get 24? So if I multiply it by 1, I get 2.4. If I multiply it by 10, I get, what's 2.4 times 10? 24. So I'm telling you, 2.4 times 10 is the same as 24. Does everybody accept that? Wear it like a cozy jacket? 2.4 times 10 is 24. I still have this 10 to the -2. Unfortunately, scientific notation is really putting us in a box. I hate it, but that's okay. Because now we've got 10 to the 1 times 10 to the negative 2. 1 plus negative 2 is? So the exponent is negative because it's a decimal. We're in scientific notation land. When we were back here in simplifying land, no negative. Here in scientific notation land, negative's A-okay. Because I did negative 5 plus 3.
What?
But scientific notation says I can't have this 24. It has to be 2.4. So I put an extra 10 on there. Because what's 2.4 times 10? Yes, it's 24. So I just replaced it with its equivalent. One thing to think about as you're doing these problems, if you're negative, you're moving left. So negative 2 means my decimal place moves left 2. When it's positive, that's how many you move right. So if I were converting 2.24 into 2.4, the decimal
Wait.
move it. If it's negative, we move it. Okay. So to get, if I were to go 24 to this one, 24 times 10 to the negative 2, the decimal would be right here. Negative 2 means I move it to the left 2. So 24 times 10 to the negative 2 is 0.24. We move that decimal 2 places. So what scientific notation says is I need the decimal right here. So I need it to be 2.4. I've got to move it back one to get 2.4. I'm just explaining it's negative. Okay. Let's give these problems a try and see if it clears it up. If your answer has 18 in it, it is not correct. So we do the multiplication of the numbers, and then we multiply the tens. 6 times 3 is 18. And 9 plus 5 is 14. So 18 times 10 to the 14 is not your final answer. Scientific notation says I can't have the decimal here. I need it to be, I can only have one number in the front. So I need that decimal to move and be 1.8. Just like we did here, we traded 24 with 2.4 times 10. We're going to do the same thing with 18. We're going to replace him with 18, 1.8 times 10. So that way now we have a 1.8 and we have a times 10 to the 15.